Good morning, students. Welcome in the lecture. So, today we are going to discuss about the topic electrostatics of your class 12th physics. Okay, so this topic electrostatics contains at least 4 to 5 questions in your NEET examination. Okay, so 4 to 5 questions, that means 20 to 25 marks. Okay, at least 4 questions. So, it contained 20 marks in your NEET examination. So this chapter is very important according to your exams. So the term electrostatics. What do you understand by electrostatics? Electro plus statics. It is made from two words, that is electro plus statics. And here electro means, what means electro? That means electricity. Okay, it means electricity. And static, that means the charge at rest. Electro means electricity. Okay, and statics means charge at rest. Okay, so in this chapter we study the charges at rest. That means electrostatics, it deals with the study of forces, fields and potentials arising from static charge. Okay, so in this chapter we study about static charges, okay, about their potentials, about their fields and about their forces. So the electrostatic defined as the study of electricity at rest. What it defines? It defines as the electricity as at rest, and this does not mean that electrons are not moving. Okay, please don't misunderstood that electricity at rest means electrons are not moving. Electrons are always moving, but it means that the body that carry the electrons, that are usually at rest. Okay, what it means? The body, okay, the body which carries the electrons are moving. Electrons are continuously moving. That's why electrons are in perpetual motion, because they are continuously moving, but the body that carries the electrons, that are usually at rest. Okay, understand? This does not mean that electrons are not moving. It means that bodies that carry the electrons, that are usually at rest. So the electrons are always follow perpetual motion. What it follow? It follow always perpetual motion. That means perpetual motion means the electrons that are always in motion. Understood, students? After that, we learn what is electric forces and charges and how they react. We know in our previous class we study about that like charge repel each other and unlike charges attract each other. What I'm saying? Like charges attract, repel each other, and unlike charges attract each other, which you can see in this diagram. That means this is the negative and negative charge, which are like charges. Okay, and these are positive charge, which are also like charges, and you can see they are repel each other. Instead of unlike charges are attract each other. So we can say that like charges repel and unlike charges attract each other. And you can see here, this is a neutral charges which does not show any effect. Okay, it doesn't show any effect. Okay, so you can see in this diagram, these are the like charges, negative, they are repel each other, and this is called repulsion. Okay, and you also see in this diagram, that is unlike signs. 1 second. Yes, this is like charges and unlike signs attract each other. After that we are moving to our next slide. That is what happens to the magnitude, the force, as the charges get farther apart. Okay, so unlike signs attracts each other and like signs repel each other. Okay, after that we will coming to our main topic, that is electric charge. Okay, in this chapter electrostatic, our first topic is electric charge. So what do you understand by electric charge? Electric charge is a property associated with matter due to which it produces and experiences electric and magnetic field. What do you understand? It is the property associated with matter, okay, but not any kind of matter. Okay, there are some matters which conduct electricity. They are showing that property, that electric field and magnetic field. Every matter in this universe does not show electric and magnetic effect. Okay, only that conductors which are the good conductor of electricity, they are showing electric effect or magnetic effect. Okay, so the electric charge is a property associated with the matter due to which it experiences and produce electric and magnetic field. Okay, students. After that, the charges are of two types. Okay, it can be of two types. First is positive charge and second one is negative charge. Okay, so the particles or the matter is positively charged when there are lack of electron. Okay, when there's a matter and they have lack of electron, that means they have very small amount of electrons. So what we can say this matter is positively charged. Okay, and the matter that have excess of electron is called negative charge. Okay, there's a one matter and there's a matter number two. The matter, we have a very small number of electrons, we called it positively charged matter, and the matter we have excess of electron, that means a very large amount of electrons that have, is called negatively charged matter. Okay, so students, I hope you understand what is positive charge and what is negative charge. Okay, this is the property of matter due to which it produces and experiences electric and magnetic field, and electric charges are of two types, which is positive and negative. Okay, lack of electron, it is positively charged, and excess of electron, it is negatively charged. Okay, so after that, like charges repel and unlike charges attract each other, and this is the fundamental law of electrostatics. Okay, this called the fundamental law of electrostatics. That means like charges attracts and like charges repel and unlike charges attract each other. Okay, after that, what is the SI unit of Coulomb? What is the SI unit of charge? Okay, we know the topic. We learned the topic of SI units, unit and measurements in your class 11. Okay, so what is the SI unit of charge? The SI unit of charge is Coulomb. Okay, what is SI unit of charge? It is Coulomb and it is represented by capital C. Okay, so after that, we learn about the property of charge conservation. How can we say that charge is conservative in nature? Why? Because charge is neither created or nor destroyed. What we call charging is either transfer of the charges or internal rearrangement of the charge carrying units. What I'm saying? We learned in our previous classes that charge can neither be created and nor be destroyed. That means we can't create a charge or we can't destroy a charge. Okay, we can't create it. It is a natural. Okay, so charge is neither created nor destroyed. What we can do, we just can do that we transfer the charges from one place to another. Okay, it is like a internal rearrangement of the charge carrying units. Okay, what it likes a internal rearrangement of charge carrying units. Okay, so in our next classes, we learn how to transfer the charge. Okay, how we transfer a charge from one place to another. After that, types of matter. Okay, there are types of matter according to flow of charges. Okay, we are talking about the charges. So according to the flow of charges, we have three types of matter. Okay, three types of matter. So the first type is conductor. We know what is conductor. The substance through which electric charges can flow easily are called conductor. Okay, what I'm saying, the substances through which electric charges can flow easily are called conductor. Example, iron, aluminium, copper, silver. These are the good conductor of electricity, and these are the basic main examples of conductor, because in this matters the electricity, the flow of electricity is going easily. Okay, it is an easy going flow of electric charge in this elements like aluminium, copper, silver. Okay, and silver is the best example of conductor. Okay, so what do you understand by conductor? The substance through which the flow of electric charges easily are called conductor. Okay, if you are talking about insulator, what is insulator? The substance through which electric charges cannot flow. Okay, the flow of electrons, the flow of electric charge completely block in this insulator. Okay, so insulator is a kind of substance in which there is a no flow of electric charges. The electric charges does not flow in insulator. So the example of insulators are plastic and wood. You see the electric current in plastic? No. You see the electric current in wood? No, because these are the bad conductor of electricity and they are called insulator. So this is also the definition of insulator. The substance which are the bad conductor of insulator are called, which are the bad conductor of electricity are called insulators. Okay, because in these substances the flow of electric charges does not happen. Okay, after this we learn a term semiconductor. This is a third type of matter. Okay, first is conductor, second is insulator, and third one is semiconductor. So what is happening in semiconductor? So the substance which are behave as insulator at low temperature and behave as conductor at high temperature called semiconductor, like germanium, silicon, etc. So what is in the semiconductor? We take a matter. Okay, we take a matter, and we are sitting in a room. Okay, so we are sitting in a room in a normal room temperature. So that matter behaves like a, behaves like an insulator. But if we increase the room temperature, if we increase the temperature of the room, then what has happened? It behaves like a conductor. Okay, if we increase the temperature of the room, it behaves like a conductor, and if we lower the temperature of the room, it behaves like an insulator. Then this kind of matters or this kind of substances are called semiconductor. They are not properly a conductor and they are not properly behave like an insulator. Okay, they are in a midway. That's why we call them semiconductor. Okay, so what is semiconductor? The substance which are behave as insulator at low temperature and behave as conductor at high temperature called semiconductor. So the main examples of these semiconductors are germanium and silicon. Okay, when some charges is given to the surface of conductor, then due to the property of conduction, that charge is distributed. What is the property of conductor? When some charge is given to a surface. Okay, let's assume there's a surface. Okay, and there's a conductor. Okay, then due to the property of conduction, charge is distributed uniformly at the surface of conductor. Okay, they are distributed uniformly at the surface of conductor. But if we give some charges to the insulator, okay, there's a conductor and there's the insulator. We give same charges to both. In conductor, we give the same charge. In insulator, we give the same charge. But in conductor, due to the property of conduction, the charges get distributed uniformly. But if we are talking about insulator, the charges does not get distributed uniformly because because of this property, the charges does not distributed to its surface. It remains at the same point where we give that charges. Okay, why? Why they remain at its same point? Because they are not follow the property of conduction, because they are insulators. Okay, so this is the difference of conduction conductors and insulators. Okay, students, so with the help of this diagram, we understand this concept more in a more easy way. Like you can see, this is a conductor. Okay, this is the conductor on, and these, there are two bands. Okay, one band is valence band, one band is called valence band, and second one is conduction band. Okay, so if you see the diagram of conductor, you see that there's a valence band and the conduction band are totally overlap each other. They are overlapping each other. So the electrons which are present in valence band, they easily going to the conduction band. Okay, they can easily jump to the conduction band. So the free electrons which is present in the valence band, they are easily going in the conduction band. So the flow of electric charges happening easily. And if you're talking about semiconductor, the gap between valence band and conduction band is not so much, but there is a gap. Okay, there is a gap between valence band and conduction band. So the electrons which are present in the valence band can jump easily. Not all the electrons, but some electrons jump to the conduction band. Okay, and they conduct electricity. There is a chance to conduct the electricity. But if you are talking about insulators now, there is not any kind of chance to conduct electricity because the gap between them is very, very, very much larger. Why? You can see there's a valence band, okay, and there's a conduction band. And you can see the valence band is full. Here, what is right? There's a full valence band and there is an empty conduction band. Okay, so the valence band is full of electrons and the conduction band is total empty. Okay, and if we see the conductor, the valence band is totally empty because all the electrons jump to the conduction band and that conduction band is totally full. Okay, with the free electrons. But if we are talking about semiconductors, the valence band is almost full. Okay, but some electrons, you can see in the conduction band, there are some electrons, they can jump to the conduction band, but the conduction band is almost empty. Not totally empty, but almost empty. Empty, that means there are some electron which is present on the conduction band. Okay, so we can say that there is full chance to conduct electricity in a conductor, and there is some chance to conduct electricity in semiconductor, but there is no chance to conduct the electricity in insulators. Okay, okay, students, understand? Okay, so after that we learn the types of charging, how we charge the one thing to another, how we transfer the charges. So there are many methods related to this. That means the rubbing method, induction methods. Okay, so first of all, we learn about the rubbing method. So what is happening in rubbing method? You can imagine with a name. What is the first thing which has come in your mind after hearing this name by rubbing method? Rubbing methods? Yes. The word rubbing. We have to rub the things. What we have to rub? When we rub two substances, then due to the friction, heat is produced. What I'm saying, when we rub two substances, you can see in this diagram, there are two substances, and when we rub them together, what is produced? Heat is produced. It is the basic phenomena now. When we rub our hands, some heat is produced. So when we rub two substances, then also heat is produced now. So due to the friction, heat is produced. So then one of the substance absorb that heat. Okay, so there are two substances, 1 and 2. We rubbed them together. Okay, so due to the friction, heat is produced. Okay, so then one of the substance, okay, one of the substance absorb that heat. The heat which is produced, one substance absorb that heat and emit electron. Okay, so this heat is absorbed by the one and they are emitting electrons. Okay, they are absorbed heat and they are emitting electrons, and these electrons are absorbed by the second substance. Okay, can you understand this cycle? The heat is produced and this heat is absorbed by the substance number 1, and the substance number 1 emitting the electrons, and that emitted electrons are absorbed by substance number 2. So what is happening here? The one which emit electrons, due to the lack of electron, it becomes positively charged, And the substance, the second one, due to the excess of electrons, becomes negatively charged substance. What is happening? The substance number one, which is emitting electrons, that means it have now the lack of electrons because it is emitting their electron now. So there is a lack of electron, and the substance number second absorb that electron. So there is a excess of electrons. Okay. So what is the property of charge? The excess of electrons called negatively charged, and the substance which have a lack of electrons called positively charged. Okay. So this is our rubbing method. Okay. And this in this way we transfer our charge. What is happening here? We transfer the charge from one substance to another substance. Okay. Okay, students. So this is called rubbing method, and this is a type of charging. Okay, this is under the type of charging. I hope you understand this method. I'm repeating this method. What we are done in this method, when we rub two substances, then due to the friction, heat is produced. Then one of the substance absorb that heat and emit electron, and second one absorb that electron. So the one which emit electron, due to the lack of electron, it becomes positively charged, and the substance, the second one, due to the excess of electrons, it becomes negatively charged substances. Okay. So these are some examples of rubbing method. Okay, the following table represent the negative and positive charged body when it is rubbed. Okay, so when we take a glass rod and silk cloth, so the glass rod becomes positively charged and the silk cloth becomes negatively charged. Why? Because glass rod having a excess of electron, so due to the rubbing, the electrons is emitted and the silk cloth absorb that electrons. That means it becomes negatively charged and it becomes positively charged. Okay, students, I hope you understand this example. Same in this kind of example, like flannel or cat skin, ebonite rod. When we rub them together, the charge get transferred. Woolen clothes and amber rod, woolen coat and plastic seat. Okay, so this kind of examples is getting charged. That means when we rub them together, the charge get transferred. So these are the examples of rubbing method. After that, the second method is contact method. Okay, by the help of contact method, we transferred our charges. How? Okay, so let's read it. When two identical shape and size conductor touches each other, you can see in this diagram there are two or more conductors. So the two identical identical shape and size conductor touches each other, where one of the conductor is charged and second one is neutral. So then by touching, charge will transfer from charged conductor to neutral conductors, and by this both will have same charges. What is happening in this method? We are taking a two identical shape and size conductor. Okay, both are identical in the shape and size. Okay, so when we when they touches each other, where one conductor is charged, okay, the one conductor is fully charged and the second one is neutral. Okay, then by touching, when they are touching each other, charges will transfer from the conductor to the neutral conductor. Okay, charge will transfer from the conductor which is totally charged to the conductor which is neutral. Okay, so and by this both will have the same charges, and this process is happening until the both conductors have the same charges. Okay, so this is called contact method. We are doing contact of these two identical shaped conductors, and by this they are getting same charge. Okay, so this is the contact method. Okay, after that, same induction methods. Two identical shape and size conductor touches each other. Okay, with the help of this diagram you can understand these are the two conductors. One is positively charged, second is negatively charged. Okay, this is A and B. And when what is happening, there is a negative charge which is outside at the surface of positively charged conductor, When we touch the negatively charged ball to the positively charged conductor, what is happening? The charge is uniformly distributed to both the conductors. Okay. Okay. So these are some methods of charging. Okay. These are the methods of charging. These are coming under the types of charging. But we are talking about the properties of charge. Okay. We are talking about the basic properties of electric charge. So what do you understand about it? Okay. So what is our first property of electric charges? The first property is additivity of electric charges. What do you understand by additivity? Additivity means we have to sum the all the charges which is present in the system. Okay, so according to this property, if a system contains n charges, that means Q1, Q2, Q3, Q4 and Q5, these are the charges which is present in the system. So if you want to find the total charges of the system, what it will be? It will be Q1 plus Q2 plus Q3 plus Q5, okay, plus infinity up to infinity or plus Qn. We can write Qn. Okay, so this is the basic property, that is additivity of electric charges. Q is equals to Q1 plus Q2 plus Q3 and up to Qn. So this is the property of additivity of charges. Okay, clear? Okay, so charge, if you are talking about the magnitude of the charge, charge has magnitude but no direction. Okay, so what we can say, it is a scalar quantity. Why? Because it only has magnitude, it only does magnitude but no direction. Okay, charge has magnitude but no direction. We can say that it is a scalar quantity. What quantity? Scalar quantity. It is a scalar quantity. Proper sign have to be used while adding the charges in a system. Okay, this is just a precaution. We have to use a proper signs. That means plus to plus, negative to negative. Okay, because if you are not using this now, our numerical is going wrong. So the proper signs have to be used while adding the charges in a system. After that, you will get a correct answer. That's fine. Okay. So our next property of the charge is, these are the basic properties. Okay. So the next properties are the charge are conserved. Okay. We learn about this property. Charges are conserved. How? According to this property, no new charges either created or destroyed. So total magnitude of the charges in initial and final condition is equal. What do you understand by conservation? And the word conservation means anything, not magnitude, anything. For that the initial condition and final condition are equal, then we can say that this is conserved. Okay, but if we are talking about charges are conserved, so this property, no new charges either created or destroyed. So we can say that total magnitude, okay, total magnitude of charges in initial condition and final condition, it is equal. Okay, so we can say that charges are conserved in nature. And our next property is quantization of charge. What do we understand by quantization of charge? Quantization of charge states that it is established that all free charges are integral multiple of basic unit of charge denoted by E. What it says? It says all the free charges, okay, all the free charges are integral multiple of the unit of charges, the fundamental unit of charges. What do you understand by fundamental unit of charges? It is the smallest charge in the world which is existing freely. Okay, the smallest charge in the world which existing freely is electron. That means the charge is 1.6 into 10 raised to the power minus 19 coulomb. This exists independently. Okay, the smallest charge which is existing independently in the nature is electron, and the charge is 1.6 into 10 raised to the power minus 19 coulomb. So in quantization of charge, it is states that all free charges, okay, all free charges which are represented by Q, are the integral multiple. Okay, all the free charges that is denoted by N, okay, are the integral multiple of E. Okay, so this expression is coming from this quantization of charges. The formula of quantization of charges, Q is equals to NE. That means N is the integer number. Here, what is N? It is the integer. It is integer number, and E is electron. Okay, so this fact is called quantization of charges. Okay, this fact, Q is equals to NE. That means all the free charges are the integral multiple of a basic unit of charge denoted by E. Okay, this is Q is equals to NE. Okay, after that, we are coming to our most important topic of this chapter, Coulomb's law. Okay, Coulomb's law, this is the Charles Augustin Coulomb's, okay, which are derived this law, Coulomb's law. Okay, so what do you understand by Coulomb's law? I'm coming to the definition. So according to the Coulomb's law, if two charges Q1 and Q2 are kept at a distance r, then forces between these two charges is, what I'm saying, there are two charges. Okay, there are two charges Q1 and Q2. Okay, these are the two charges Q1 and Q2 are kept at a r distance. Okay, I'm making a diagram. Okay, these are the charges which are kept at r distance. Then forces between these two charges, we have to find the force. What kind of force? Electrostatic force between these two charges is directly proportional to the product of two charges. Okay, what I'm saying, it is directly proportional to the product of their two charges and reciprocal to the square of distance between these charges. Okay, and the reciprocal to the square of the distance. That means distance is r and we have to do the square. Reciprocal to the square of distance between these charges, it means F is directly proportional to 1 upon r square. So if we combine this and this, what we will get? We will get this value, that is this expression, that is F is directly proportional to KQ Q1 Q2 upon r square. Okay, so if we remove this sign of proportional, what is coming here? The K, which is a Coulomb constant, and the value of Coulomb constant is 9 into 10 raised to the power 9 Newton meter square. Okay, so after that expression will be F is equals to, this is not a sign of, it is equal, F is equals to K Q1 Q2 upon r square. Okay, students, so this is the Coulomb's law. What Coulomb states that according to Coulomb, if two charges Q1 and Q2 are kept at r distance, then forces between these charges are directly proportional to the product of two charges and reciprocal to the square of the distance between these charges. So after that, if we are mathematically represent it, it will be F is directly proportional to Q1 Q2 upon r square, and if you remove the sign of proportionality, the value of Coulomb constant, that is represented by K, is coming. Okay, so the expression will be F is equals to K Q1 Q2 upon r square. Okay, students, I hope you understand this. What is Coulomb's law? Okay, so now this is the expression, that is F is equals to K Q1 Q2 upon D. We can also write D square. D is also distance, R is also distance. Here charge is in Q. What Q represent? Q represents charge in coulombs. Okay, charge in coulombs. K represent the Coulomb's constant and D represent the distance in meters. Okay, so compare this to the gravitational force. Okay, we learn about the gravitational forces in your class 11th. Yes, so this law is totally similar to the gravitational law. Okay, so that's why I'm comparing this right now. The gravitational force, the value of gravitational force in the chapter gravitation, we derived this like G m1 m2 upon d square. Okay, here totally same, like this is force, that is electrostatic forces, K Q1 Q2 upon R square. Now this is totally a same. Here F is the electrostatic force. Here Fg is a gravitational force. Here K is the Coulomb constant. Here G is the gravitational constant. Here Q1 Q2 are the charges, and M1 M2 are the masses, and R is the distance, and here D is the distance. Okay, so this is the totally same kind of expression. That's why we are comparing this expressions. Okay, so I hope you understand Coulomb's law. What is Coulomb's law? Two charges Q1 Q2 are kept at R distance. The forces between two charges is directly proportional to the product of their masses, and inversely proportional to the square distance between them. Okay, so there are two cases in Coulomb's law. Okay, there are two cases. First case, when both charges situated in vacuum, okay, the charges Q1 and Q2 both are situated in vacuum. So first case is this, and second case when both charges situated in medium. So firstly, we learn about first case, that is the charges situated in vacuum. So what is happening when the charge is situated in vacuum? Then what is happening? The value of K we know. Okay, we know the value of K is 9 into 10 raised to the power 9. Okay, but the value of K is also, it is also the value of K, which is 1 upon 4 pi epsilon naught. Okay, and the value of this now, this expression is 8.85 into 10 raised to the power minus 12. Here epsilon naught is the permittivity of free space. Okay, what epsilon naught represent? This represent the permittivity of free space. Okay, because we are situated both the charges in vacuum now. That's why we can say that E naught epsilon naught is a permittivity of free space. And when both charges situated in medium, then what is the value of K? The value of K is 1 upon 4 pi epsilon. Not epsilon naught. It is just epsilon. And here epsilon is a permittivity of the medium. Okay. In first case, epsilon naught represents the permittivity of free space because it is situated in vacuum, and vacuum is also the free space. And here epsilon represents the permittivity of medium. So why? Because they are situated in medium. That's why we can say that K is equals to 1 upon 4 pi epsilon. Okay. So these are the two cases of Coulomb's law. Okay. So there is also expression related to the permittivity. What kind of expression? Okay. Let me drop this firstly. So there is an expression related to the permittivity of the medium, which you can see in this slide. Okay, so the relation is epsilon naught multiplied by epsilon r is equals to, sorry, it is not epsilon r, it is epsilon. Let me take a eraser. It is epsilon. It is not epsilon r. This is a mistake, and this is the epsilon r. So this is the relative permittivity. Okay, this is the relation of epsilon naught and epsilon, that is called relative permittivity. If we multiply epsilon naught, that is permittivity of free space, is multiplied by permittivity of medium, what we get? We get the relative permittivity. Okay, so this is also the expression, that is if epsilon is equals to epsilon r upon epsilon naught. Here there are some values of permittivity. So the value of permittivity in the vacuum is 1. The value of permittivity in the air is 1.00054. The permittivity of water is 80, and the permittivity of metal is infinite. These are the some values which you have to learn, because they are using in some numericals Okay, basically the values of permittivity is given in the numerical, but if it is not given, you have to learn this. So, because these are very easy. Okay, metal ki infinite, in water permittivity is 80, in vacuum 1. You just have to learn the permittivity of air. Okay, okay. After that, we are learning we learn a Coulomb's law. Okay, after that, we learn to calculate the Coulomb's law in vector form. Okay, what we learn? We learn the Coulomb's law in vector form. So what do you understand by Coulomb's law in vector form? Why it is different from the Coulomb's law? Because in vector form, it also gives the direction. Okay, it also define the direction, but in Coulomb's law, it doesn't define the direction. It only calculates the magnitude of force. But the Coulomb's law in vector form uh, let make us know the direction of forces. What is the direction of forces? That is called Coulomb's law in vector form. Okay, you can see this diagram. These are two charges, Q1 and Q2, which is situated at r distance. Here it is F21 and it is F12. Okay, these are the forces of a force on Q charge due to charge number 2, and this is force on Q2 charge with respect to charge 1. Okay, how to find it? There is a equation to find a Coulomb's law in vector form. Okay, there is an equation. What is the equation? The equation is F12 vector is equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R12 ka whole square multiply by R cap 1 2. Okay, I'm writing it here. This is F vector, and here 1 2 is force on charge number 1 due to charge number 2. Okay, what it represents? Force on charge 1 due to charge 2 is equals to 1 upon 4 pi epsilon naught is it represents k, and q1 q2 it is same upon r square radius. You can also write it r12. Okay, so it is r cap. Total formula is same, but just the r cap is here. Okay, and this r cap represent the direction of this force. Okay, this represent the direction, the r cap. Okay, so what we can say that the value of F12 vector is equals to the value of F21 vector. Just it is opposite. Okay, how? Here F12 is the force exerted by Q1 on Q2 charge. Okay, what F12 represent? The force exerted by Q1 on Q2, and F21 is the force exerted by Q2 on Q1. Okay, understand the terminology of this 1 2 or 2 1. So the Coulomb's law holds for stationary charges only. This is the point. Coulomb's law holds for stationary charges, that means point charges. Okay, Coulomb's law holds for stationary charges or point charges. The charges which is present on the Coulomb's law are point charges. Okay, they are a point sized charges, or we can say they are stationary charges, that means charges at rest. So which are point sized? So this law obeys Newton's third law. So what we can say that these law obeys Newton's third law, because F12 is equals to minus F21. So what we can say that it obeys Newton's third law. And what is the Newton's third law? Every action has equal and opposite reaction. What is the third law of Newton? Every action has equal and opposite reaction. So this reaction represents, this is the charge are equal, but they are opposite in nature. Okay, the charges are equal, but they are opposite in nature. That's why we can say that this law obeys Newton's third law. Understand? So what is the Coulomb's law in vector form? Same as Coulomb's law, only we multiply the r cap. Okay, and they obey Newton's third law, which is represented by this equation. So after that, this is the vector form. Okay, we can calculate our vector form in by this formula. So after that, force on charged particle due to a number of point charges is the resultant of the force due to individual point charges. Okay, what I'm saying, this is the case of multiple charges. Okay, we are talking about only two charges here, Q1 and Q2. But if we are, there are many charges which is present in the system, and then we have to find the force. What we have to do? So this is the case. Force on the charged particle, that is charged particle Q, due to the number of point charges. Okay, the number of point charges is the resultant force due to the individual point charges. Okay, it is the resultant force due to the individual point charges. That means F is equals to F1 plus F2 plus F3. Mathematically, we can represent this by this. Okay. After that, our main topic is force of multiple charges. How to find the force of multiple charges? If the multiple charges are present in the system, how can we find the force? So consider a system of n charges where Q1 and Q2, Q3, Q4. These are the charges. Okay, Q1, Q2, Q3, Q4. These are the charges present in the system. Okay, up to Qn. Located at R1, R2, R3, and R4. Okay, they are located at this is the distance. Okay, and this is the position vector. These are the charges. This is the value of the charges, and this is the position vector. Why we are taking vector? Because we are talking about the Coulomb's law in a vector form now. So that's why we are talking about the position vectors. So let us consider that in another charge Q naught. Okay, we have another charge Q naught is located at R naught. These all the charges Q1, Q2, Q3 located at R1, R2, R3. Now we consider a Q naught charge which is located at R naught. Then total force on Q naught, if we are talking about the total force on Q naught charge is equal to the vector addition of all the forces. Okay, which is equal to the vector addition of all the forces exerted by individual charge. Okay, so this is the termed as principle of superposition. Okay, this is also called the principle of superposition, forces of multiple charges. Okay, so this topic, principle of superposition, we learn about this in our next class because it is a bigger topic. Okay, so this termed as a principle of superposition, that means the forces of multiple charges. We can also say that principle of superposition. Okay, we can also termed as principle of superposition. Okay, okay students, thank you. We will learn about this in our next class.